In this video, we're going to continue to discuss the idea of the structure of the atom and all of the different parts to the atom. So what I would like to do is I'd like to look at one individual atom from the element of nitrogen. So if I'm talking about the element of nitrogen, I'm talking about a substance, a piece of matter in which all of the atoms are exactly the same, and they are nitrogen atoms. Originally, we thought of these atoms as solid little spheres, but we've learned from the last two videos that these atoms are not solid spheres, but they have an inner part and they have an outer part. The inner part, we found out, was the nucleus. The nucleus is the inner part of the atom, and it contains the protons and neutrons. So there's an inner part of the atom. That means there must be an outer part of the atom, and that is the electron cloud, the outer part of the atom. Now, the outer part of the atom only contains electrons. So here's how we're going to begin reading the periodic table. The first thing that I want to point out to you is this number on the top is called, it has a term, it's termed the atomic number. So the atomic number is going to indicate to us two things. The atomic number will give us the number of protons in the nucleus, but it'll also give us the number of electrons in the electron cloud. So that atomic number is going to be very, very important. Here, for nitrogen, the atomic number is 7. The atomic number is 7. And we can notice that the periodic table is actually organized according to the atomic number for each atom. 1, 2, 3, 4, and it continues on all the way until we would get to 118. This piece here had not been created yet by scientists. Remember that almost all of the atoms have been were originally created, but about 28 of them have been created by scientists in a lab. So this atomic number 7 here indicates something to us, and that atomic number is going to indicate to us two pieces of information: the protons and the electrons. The protons are on the inside of the atom in the nucleus, and the electrons are on the outside of the atom for the electron cloud. So if I were going to draw a structure draw the atom of nitrogen where it has a 7, what I would do is I would draw 1, 2, 3, 4, 5, 6, 7 protons in the nucleus. Now I realize that that is very small, but based off the last video we just watched, the nucleus is the smallest part of the atom, all packed tightly together. Now I'm going to draw the outer part of the atom. Now, we haven't talked about this, but nitrogen is actually broken up into two areas of space. The outer part of the atom is broken up into two areas of space. Now I'll hint at how we're going to know that. Because nitrogen is in row number 2, that indicates to us that there's two areas of space for the outer part of the atom. Now, there are 7 electrons. Notice, the atomic number gives me the number of protons that are in the nucleus. It also gives me the number of electrons in this outer part, the electron cloud. It turns out that there's 2 electrons in the first area of space, and I'll draw those with a different color. 2 electrons there, and then 5 of them in that second area of space. So let's identify this. So first off, let's identify this in the middle as the nucleus. We'll call this the nucleus. And there's so far 7 protons in the nucleus. And we're going to call this atom nitrogen. Nitrogen. So 7 protons all packed tightly together. There's also the electron cloud. That's the outside of the atom, this whole outer area. And there are 7 electrons distributed around the outside of the area. We found out that the electron cloud has 2 areas of space. This inner area, you can think of the inner area here like a ping pong ball, and there's 2 electrons flying around the surface of the ping pong ball, and maybe this like the surface of a tennis ball, and there's 5 electrons flying around the surface of the tennis ball. We will work on that details during the next video, but I want to tell you that the 2 areas of space come from the row number, and the reason I know that there's 5 electrons on the outer area is because of the 5A here. We'll look at those details in the next video, but I'm just giving you some hints about what we'll be doing and what it looks like. Now, we also know that nitrogen, its nucleus contains protons, but it also contains one other type of subatomic particle. And the other subatomic particle are the number of neutrons. And notice, I'm not putting a number in there right now. It turns out that no matter what type of nitrogen atom you're dealing with, it will always have 7 protons and 7 electrons. But the number of neutrons can be different from one atom to the next. So that means we need to have a formula to be able to find the number of neutrons. And the way we're going to find the neutrons is by this. We're going to use what is called the mass number. And the mass number is equal to the number of protons plus the number of neutrons. Or we can use the atomic weight rounded to the nearest whole number to find the mass number. So when we don't have enough information to use this equation, we're going to use the atomic weight rounded to the nearest whole number. So notice here, this is going to be our atomic weight. They use the word atomic mass or atomic weight interchangeably. So you can think of this as the atomic weight. So we can take that number, round it to the nearest whole number, and that will be the mass number, and that'll be able to allow us to find the neutrons once we know those two pieces of information. So finally, the last thing that I want to point out is, if you look at the nucleus, there is a force that holds the nucleus together, and the force that holds the nucleus together is called the strong force. So strong force is the force that holds the nucleus together. And the force that holds the electron cloud together, is what is called an electrostatic attraction. That's the force. That just means opposites attract. The positive protons are attracted to the negative electrons. All right, I hope this helps in understanding the structure of the atom. We will continue to elaborate on finding the number of protons, finding the number of electrons, as well as finding the number of neutrons.